Let's take a look at this new engine and if it is the future of space travel. Exploring the universe for centuries, ever since we realized that every star we can see in the night sky is a sun just like our own, with perhaps its own solar system, planets, and possibly even life, humanity has dreamed of crossing the astronomical distances separating us from the ultimate alien destinations. In this video, we'll uncover the science behind this exciting technology, its strategic implications, and how it stands to transform our approach to exploring the cosmos. Even the nearest star is more than 4 light-years away, while the fastest speed a human-created spacecraft has ever traveled at, reached by NASA's Juno mission, is a mere 46 mph. Even at that speed, it would take more than 4,000 years to reach the nearest star. There are 2 limiting factors: the current limits of our technology and the laws of physics. Advances in fields like laser sails, nuclear propulsion, or producing and controlling either antimatter or dark matter could provide a game-changing technological breakthrough, but appear to lie far off in the distant future. But physics-defying technologies, despite being often touted as the future, are fundamentally flawed. There are 4 fundamental forces in the universe: gravitation, electromagnetism, and strong and weak nuclear forces. The first of these forces is described by general relativity, the best theory of gravity we've ever concocted, and one that's passed every observational or experimental test we've ever performed. The latter 3 are described by the Standard Model, which describes all the known particles and their interactions exquisitely, passing every classical and quantum test we've ever devised. As for the helical engine, while it is intriguing, it is unlikely to defy the laws of physics anytime soon. Despite the claims, although it has been met with skepticism from some quarters, Burns believes his concept is worth pursuing. In its simplest terms, the engine works by taking advantage of how mass changes at the speed of light. One way to break down this concept is to envision a ring inside a box, attached to each end by a spring. When the ring is sprung in one direction, the box recoils in the other. As is described by Newton's laws of motion, every action must have an equal and opposite reaction. When the ring reaches the end of the box, it will bounce backward and the box's recoil direction will switch too. However, if the box and the ring are traveling at the speed of light, things work a little differently at such speeds. According to Albert Einstein's theory of relativity, as the ring approaches the end of the box, it will increase in mass. This means it will hit harder when it reaches the end of the box, resulting in forward momentum. Generally speaking, the engine itself will achieve a similar feat using a particle accelerator and ion particles. This is because chemical, nuclear, and electric propulsion systems produce thrust by accelerating and expelling propellants. Deep space travel is often a trade-off between thrust and large propellant storage tanks that eventually limit performance, and this is what makes this idea so compelling. Drive Burns states that the objective of this paper is to introduce and examine a unique engine that uses a closed-cycle propellant. The design is capable of producing a thrust up to 99% the speed of light, without breaking Einstein's theory of relativity. However, the plan does breach Newton's law of motion, violating the laws of physics. That's not the only thing holding the helical engine back. Scientists believe the engine would have to be 650 feet long and 40 feet wide to work. Additionally, it would only operate effectively in the frictionless environment of deep space. While the M drive has been proven to not work and the helical engine is yet to be properly reviewed, NASA has continued to fund research in an attempt to look for more alternatives. Most recently, the agency has announced it is investing $2 million over the next 2 years to advance the development of a new solar sail concept called diffractive light sailing. Burns has worked on his design in private without any sponsorship from NASA, and he admits his concept is massively inefficient. However, he says there is potential to harvest much of the energy that the accelerator loses in heat and radiation. He also suggests ways that momentum could be conserved, such as in the spin of the accelerated ions. This has not held him back, though. He states that he is prepared to be embarrassed if he is wrong, but if he is not, humanity will have discovered something truly revolutionary. Elon Musk and SpaceX. NASA is not the only organization looking for ways to travel faster in space. Elon Musk is taking science fiction a step closer to reality. His company, SpaceX, says it has created a thruster system that defies physics and has successfully tested it. The rocket propulsion system uses electrically charged gas and can achieve speeds up to 65 kilometers per second, or about 135,000 miles per hour. The engine is made from super lightweight carbon fiber fuel tanks with cold gas thrusters. It doesn't use any type of propellant, meaning it does not expel any byproducts into space. Instead, the engine produces thrust by accelerating superheated plasma with magnetic fields, which also means no fumes are being expelled from combustion. These types of engines are known as electric thrusters, but they work very differently from those used in SpaceX's Falcon 9 rockets. These thrusters create thrust by propelling pressurized gas, whereas electric ones produce a charged plasma that emits ions push a craft forward. The electric engine developed by SpaceX is reportedly more powerful than conventional gridded ion thrusters and could power manned missions to Mars and beyond. It could also cut down on travel time for space-bound cargo because it requires less propellant, which can be expensive to launch into orbit. The technology is still being tested and further development is needed before it will be ready for spaceflight. It has been submitted for peer review, and NASA experts think it has potential, at least on paper. Some say it's impossible to travel at high speeds through space, but that hasn't stopped Elon Musk from claiming he can do it. His idea is to create a Lightspeed engine that will take us to Mars in just 70 days. Such an engine defies physics and would mean traveling faster than 186,000 miles per second. There are a few ways that we could travel at light speed, but first, we need to understand how light works. As it travels through space, every atom in its path interacts with it. This slows it down and even stops it completely if there's no matter around to pass through. Because of these interactions, light has a maximum velocity of 186,000 miles per second, meaning that's as fast as it can go through space. Since nothing can travel faster than light without breaking the rules of physics, if we want to catch up with a distant star in our lifetime, we have to find another way to get there besides traveling directly towards it. How far away are we from light speed? The current way that we measure speed is the distance over time. To travel at light speed, or 186,000 miles per second, you would need to accelerate past that velocity until your speed was 186,000 mph, then hold it there for an infinite amount of time. This velocity is referred to as c and was defined by Albert Einstein in his theory of special relativity. Imagine discovering all the unseen and hidden parts of the universe. The universe is expanding, and while we have had major breakthroughs in the field of astronomy, the Helix engine or the Lightspeed engine will only bring more information about the deep space, and also could bring answers to troubling questions such as how space began and how all of us got here. Imagine astronauts going to planets and galaxies that we thought we couldn't explore. That would be something.